In this video, we want to find the partial fraction decomposition of this rational expression here. We have a rational expression. We want to find out what rational expressions were added or subtracted to come up with this. So we're going to break this down. Number one, though, you have to make sure that it's a proper rational expression. So we want to make sure that the degree of the numerator is less than the degree of the denominator. The numerator has degree 2. Got an x squared there. You have an x for this factor, and this is x here, but you got a square, so this has degree 3. So the degree of the numerator is 2. The degree of the denominator is 3. 2 is less than 3, so we're okay there. And we have different situations you can have when you have, say, linear factors. X plus 2 is linear. X minus 1 by itself is linear, but then you have a square here. We still have a linear factor in x minus 1. So here's the way it works. For every linear factor, you'll have a constant. We'll call it a. And that's going to be over the linear factor x plus 2. Now let's suppose we didn't have this 2 here. It was just x minus 1. Then you would have another expression, rational expression, b over x minus 1. And the objective then would be to find the constants a and b, so that when we add these two rational expressions, we will get the original one over here. This type of problem comes up in more advanced mathematics, such as calculus, when you're finding the integral of an expression and you want to simplify it to make it easier to evaluate. Now, this would be the setup if I didn't have this exponent of 2 here. Now, if you have linear factors repeated, then I'd have to add another expression here, another constant c. And again, it would be x minus 1, but it would be squared. If this had a 3, then I'd have another one over here. Constant on top would be d, and it would be x minus 1 to the third. So that's the setup for this one. But now we want to find the values of a, b, and c. So one way to do this is to multiply through by the LCD, lowest common denominator, which would be x plus 2, x minus 1 squared. Now if I multiply through, obviously everything in the denominator on the left side will cancel, and I would get x squared plus x is equal to. Okay, on the right side, I'm multiplying, remember, by x plus 2 and 2 factors of x minus 1. So it would be x minus 1 squared. That's the lowest common denominator. So if I multiply the left side by that, obviously they reduces to x squared plus x. Now for this one here, you notice the x plus 2 is going to cancel. And that's going to leave me a constant a, and that'd be multiplied by x minus 1 squared. And the next one has an x minus 1, so that's going to cancel one of the factors here. So I'll write it as b, and I'm still going to have x plus 2 and 1 factor of x minus 1. And then for the third expression, I'm going to have the c, and that x minus 1 squared and this x minus 1 squared. That's going to cancel, so it's going to leave me with x plus 2. And then you treat this as an identity. We want to find the values of a, b, and c. So here's what we'll do. Treat this as an identity. You can pick any values you want, but we want values that are convenient. So let's let x equal to 1. I could pick 3, 4, 5, 75, whatever, but I want to be convenient so that certain things will cancel. So notice, if I pick x to be 1, put a 1 there where the x is, this will give me 0 times a. This is going to cancel. You put a 1 here, 1 minus 1 is 0, that's going to wipe out this. All I have left then is a 1 and a 2 here. So that's going to give me a 3c. And what do I have on the right side? Put a 1 over here, 1 there, and a 1 squared is 1. 1 and 1 is 2. Divide by 3 here. This cancels out. So I get that c is equal to 2/3. And that's the value that we went for c. So let's replace it here. The value that will work here for this one would be 2/3. Now let's go back over here. Let's pick another number. We picked x to be 1. What if x is, let's let x equal to, a minus 2 will cancel this factor over here. So let's pick x to be minus 2. And we do the same thing. So minus 2 over here on the left side, minus 2 squared is 4, and a minus 2 here for x is 2. And on the right side, a minus 2 here, it gives me 0 times c, so I guess wipes this out. And a minus 2 here for this one is minus 2 and 2 is 0. That wipes this out. So I'm left with a factor, so I'm left with a here. And then this is going to be a minus 2 here and a minus 3. That's squared, that would be a 9. Divide through by 9 here to solve for a. The 9's cancel out. And I get a is equal to 2/9. Then I can come back over here, replace the a by 2/9. And that's what this constant should be. Now we need the value of b. So we can pick any number. I'm going to let x equal to 0. You could pick x to be 7. You still get the answer. It might be more involved. But let's pick 0 here. So put a 0 where the x is throughout this equation here. So 0 on the left side, 0 squared is 0 plus x is 0. That's going to be 0. So on the left side, I'm just going to get a 0. Now here, remember we know the value of a. A is 2/9, so I'm just going to put 2/9 here. We're trying to find b. So a is 2/9. And the x is 0, so this will be 0 minus 1 is a negative 1, and you square it, you still get 1. So this will be 2/9. This will stay just 2/9, and then we have plus b. Put a 0 where the x is, so this will be 0 and 2 is 2. And 0 minus 1, that's a negative 1, so that'll be negative 2. It'll be negative 2b. Let's just write it this way. Again, replacing the x by 0 gives me 2 here. And minus 1 here, 0 minus 1 is a minus 1, that'll be negative 2b. And then we got a plus. Now, c, of course, we just found earlier, so this will be 2/3. And then over here, 0 and 2 is 2. This will be times 2. So let's take this to the other side over here. So this will be 2b. That comes over. And then we have 2/9 plus 4/3. This is going to equal to, so we got 2/9, common denominator here, this will be 8 multiplied by 2, 8 over, I should say 12, and the common denominator to be 9, so multiply by 3 and 3, this will give me 12 over 9, so this gives me 2 and 12 is 14 over 9, and then we divide both sides by 2 or multiply by 1/2. This is equal to this, so multiplying by 1/2. The 1/2, the 2 cancels over here. It'll give me a b, and 1/2 times the 14/9 will give me 7/9. So b then is equal to 7/9. And this is called the partial fraction decomposition of that rational expression. The more factors you have in the denominator, the more complicated it gets, because you're going to have more variables or constants. You could have as many as, here we have 3 unknowns, you could have as many as 4 or 5. Now you could also set up a system of equations here. And maybe I'll do that in another video. But this is probably the easier way if you follow this procedure here. You set it up this way, multiply through. There's also a cover method that you can use, which basically is an abbreviation or shortcut for what I have right here. But this is the answer for this problem. The constants are 2/9 over x plus 2, 7/9 over x minus 1, then plus, of course, 2/3 over x minus 1 squared. Now you can multiply here and write the 2 on top. The 9 can multiply the x plus 2. Here would be a 7, and then multiply by 9. The 9 multiplies the x minus 1. And over here, multiplied by 3 is your 2, and the 3 multiplies the x minus 1 squared. Thanks for watching. We'll see you next time.